Welcome back to my channel, guys. In this video I'll be explaining about the passive elements. If you haven't watched my previous video, go watch it first for the clear understanding. Anyhow, so passive elements. Passive elements. Passive elements are the elements which are capable of consuming energy are termed as passive elements. The elements which are capable of consuming energy are termed as passive elements. Example for the passive elements is resistor, inductor and capacitor. Resistor, inductor and capacitor. Here you may get the doubt, why we are considering the inductor and the capacitor in this category. They are used to store the energy and they can supply the energy, right? But this is done only for the short duration of the time. So we'll be considering these two also in this category, passive elements category. We'll be discussing about the resistor in detail first. Okay, resistor. What is a resistor? A resistor is nothing but a material which opposes the flow of current. It is represented by the letter R, and the units for the resistor is ohms. Okay, it is denoted by the symbol. Let the value of the resistor is R. The current flowing through it is I. The voltage across it be V. Okay, now by Ohm's law, voltage across the resistor V is equal to current flowing through it into the value of the resistor. V is equal to I into R, and the current across the resistor I is equal to, from this you can know what is I, V by R, right? The power delivered across the resistor, P is equals to V into I. This is the general formula, V into I. But what is the value of V? I into R, right? By substituting it, V is equal to I into R, right? V is equal to I into R into V. That is equal to I square into R. Or by substituting the value of current, we will be getting P is equal to V square by R. These are the formulas. Okay. Now, energy, heat loss from the resistor is equal to the energy released. Heat loss from the resistor is equal to energy released. Basically, heat loss is nothing but energy. We know that energy is equal to integral P dt. What is power? So what is power? Power is I square R dt. There is no t term in this, so everything will be treated as constant. So I square R into integral of dt, 1 dt, it is t. This is the formula for energy. Power can also be written as V square by R, or V square by R into T. This is the formula for the heat loss. Now we'll be discussing about the resistors connected in series and parallel as well. So, resistors connected in series. How to identify whether the resistors are connected in series or parallel? For example, consider a resistor R1 and consider the another resistor R2. If the first end of the resistor is connected to the start of the second resistor, then they are said to be in series connection. Or the second catch here is, consider this is a circuit. Current will be flowing from the positive terminal to negative terminal, okay, from the higher potential to the lower potential, okay. The current here is not being divided. The current flowing to the resistor will be flowing to the same amount to the R2. For example, what I mean to say is, the current does not have two paths to get divided, like here I1, I2, like that. It is constant. So by coming to know that the current is constant, we can also tell the resistors are connected in series. In series, the current is constant, okay. So potential is being divided. Total potential will be equal to potential across the resistor R1 plus potential across the resistor R2. We know that from Ohm's law, I into R equivalent. Total circuit resistance will be equal to I into R1 plus I into R2, because current is constant, okay. Taking common I and cancelling it on the both sides, we get R equivalent will be equals to R1 plus R2. Okay, now R equivalent, the maximum value of R equivalent will be maximum of the R1 and R2. That is, what I mean to say is, if you have a resistor 5 and 3, R equivalent will be the maximum of the maximum value. It will be greater than the 5 always, okay. Now resistors connected in series, resistors connected in parallel. A resistor connected in parallel, if this is a resistor R1 and this is a resistor R2, if the starting ends of the resistor and the endings of the resistor are joined, then such combination is said to be, starting point and ending point are connected, then such combination is said to be in parallel. For example, this is a circuit, okay. Current always flows from the positive terminal to the negative terminal of the battery, and here at this node the current is being divided. The current flowing through here is I, and the current flowing in this part is I1, and the current flowing in this part is I2. The current is being divided at this node, and in parallel voltage is constant, current is being divided, okay. So current I is equal to I1 plus I2 is equal to I1 plus I2. From Ohm's law we can write this, V by R equivalent is equal to, voltage is constant, V by R1 plus V by R2. So 1 by R equivalent will be equals to 1 by R1 plus 1 by R2. That implies R equivalent will be equals to R1 R2 divided by R1 plus R2. This is the formula, and the value of the R equivalent is minimum of R1 and R2. That is, for example, consider R1 is 2 and R2 is 3. The value of R equivalent will be always less than the minimum value 2. This is the example, okay. Now we will be discussing about the inductors. So inductors are the materials which opposes the rate of change of current, How to remember this? Here is a catch. Inductor starts with the word I, and which opposes the rate of change of current, okay. It is denoted by the letter I, and the units for the inductor is Henry, okay. The units for the inductor is Henry. The symbol for the inductor is as follows. This is the symbol for the inductor. Let us assume the voltage across the inductor is V. The current flowing through it is I. This is L. Okay. By the definition, we know inductor opposes the rate of change of current. Rate in the sense denominator is dt. Okay. Opposes the rate of change of current, di by dt. It opposes. Opposes means inductor is inversely proportional to rate of change of current. Okay, L is inversely proportional to di by dt. Got it? By comparing the Ohm's law, V is equal to I into R. This is a constant. This is I and this is V. I parameter is already completed, so V parameter is missing. So by removing the proportionality constant, keep the V parameter here. L is equal to V divided by di upon dt. Okay, what do we get by simplifying it? V is equal to di by dt into L into di by dt. Okay, this is the voltage across the inductor. We got the voltage across the inductor. We need to find the current across the inductor. What we'll be doing? We'll be sending L this side and integrating with respect to t. So we'll be getting the current. See, V by L is equals to di upon dt. Okay, di will be equals to V by L dt. Integrating on both sides, we get I is equals to 1 by L is a constant, integral V dt. Limits from 0 to t you can take like that. Now power delivered across the inductor. P is equals to V into I. We know what is the value of V. L into di by dt. Substitute here. L into di by dt into I is equal to power. This is the value of the power. Now energy dissipated or heat loss by the resistor is equal to E is equal to integral P dt. What is P? L into I into di by dt. L into I into di upon dt into dt. Okay, this dt gets cancelled. What's remaining? L integral I di. Integral of I di, that is equals to L into I square by 2. Energy is equals to half L I square. Now when the inductor is connected in series, what happens? What is the equivalent inductance? Okay, this is inductor L1 and this is inductor L2. They are connected in series, end to end. Okay, now equivalent resistance L equivalent will be equals to L1 plus L2. It is just similar to the case of the resistors. Okay, inductor when they are connected in parallel, inductor connected in parallel, L1 L2. Okay, here the L equivalent will be equals to L1 L2 divided by L1 plus L2. This is about the inductors. And coming to the capacitors, which the materials which opposes the rate of change of voltage. Already I is completed in inductor part, so the remaining parameter is V. So in capacitors which opposes the rate of change of voltage. Okay, rate of change of voltage is nothing but rate in the sense denominator dt. It opposes, so inversely proportional to capacitor C. C is inversely proportional to 1 by dV by dt. Okay, already V parameter is completed. So by removing the proportionality constant, we will be introducing one parameter I by dV upon dt. So by simplifying it, by multiplying it with C, I is equal to C into dV upon dt. This is the current flowing to the capacitor. Okay, capacitor, it is denoted by the symbol C, and the symbol for the capacitor is this, and the units for the capacitor are farad. Okay, now in order to get the voltage, we'll be doing some calculations. Okay, dV by dt is equal to 1 by C into I. 1 by C comes to the denominator, and dV is equals to 1 by C into I dt. On integrating on both sides, V will be equal to 1 by C integral I dt. This is the formula. Now current is completed, voltage is completed. Now the parameter is power. Power delivered across the capacitor, across the capacitor is equal to power is equal to V into I. But we already know what is I. I is equal to C into dV by dt. Okay, V into C into dV by dt. Okay, the value of I. Okay, power is equal to CV into dV upon dt. This is the power value. Now the energy dissipated. Energy dissipated or energy loss in the form of heat or heat released. Okay, energy is equal to integral P dt, that is equals to integral P. What is P? P is nothing but C V into dV by upon dt into dt. dt gets cancelled. Okay, integral C is a constant, bring it out. C V dV, that is equal to C into V square by 2, integral V square by 2. Energy is equals to half CV square. Okay, capacitors in series. Capacitor in series, it is just opposite case of the resistors. C equivalent will be equals to C1 C2 divided by C1 plus C2. And capacitors connected in parallel. Capacitors in parallel. Okay, C equivalent will be equal to C1 plus C2. Capacitors connected in series, C1 C2. Capacitors connected in parallel, C1 C2. The C equivalent will be equal to C1 plus C2. Now let's have a quick recap of what we have studied. Okay, for that I have already written these formulas in one page so that you could have a screenshot. Okay, I will be explaining a resistor, inductor and capacitor. The resistor is denoted by the symbol R and the unit for resistor is ohms. Inductor is denoted by the symbol L and the unit for the inductor is Henry, and the capacitor is denoted by the symbol C and the unit for the capacitor is farad. Okay, the formula for the voltage for the resistors, the value of V is equal to I into R. For the inductors, the voltage across the inductor is equal to L into di by dt, and the voltage across the capacitor is equal to 1 by C into integral I dt. The current I is equal to, from this above formula, I is equal to V by R, right? V by R. I is equal to, on integrating V, we will be getting the value of I. I is equal to 1 by L integral V dt. I is equal to C into dV by dt. On differentiating this, we will be getting this. Okay, power is equal to V into I, right? What is V? I into R. So I into I into R. I square into R. V by R. Okay, this is a formula for the power in case of inductor, and this is a formula for the power in case of capacitor. The energy is equal to P into T. I square R into T. And energy is equal to half Li square, and energy is equal to half CV square. Series. When the resistors are connected in series, सीधा R1 plus R2 को add करो. L equivalent is equal to L1 plus L2. Whereas when the capacitors are connected in series, it is just opposite to the case of the resistor. C equivalent will be equal to C1 plus C2, C1 C2 divided by C1 plus C2. Parallel, L equivalent and C equivalent. And that's it for today, guys.